You've been given all of this information in a table about G prime and G double prime, and you're asked to do a series of things starting with the location of max and min. And I think it's much easier to see what's going on if we look at a graph of the derivative and not in table form. So I'm going to build a graph out of this table. When x is -4, my first derivative is 1, and I'll put a dot there. So I've went ahead and plotted the rest of the points on the derivative, and I'm just going to connect them with the curve. We were undefined at x equals -2, so I'm going to put an open circle when x is -2, and I'm going to continue on. So here is my derivative, and we know that we have maxes when the derivative changes signs from positive to negative. I see that here, positive to negative. That must mean I have a max at x equals 2. So far, that's all I can tell. I'm going to go ahead and draw a max here. And I can see that I have positive derivative. All of these numbers are positive. So that means I'm going to increase somehow up to that max. I don't know how I increase, but I know I increase. So now I can answer the first few questions. I know that I have a max at x equals 2, and there are no mins because my derivative is never changing from negative to positive. I can also determine when the interval of f of x is decreasing because I can look to see when my derivative is less than 0. So I've got values from 2 to 4. That's the interval. And now to find when I'm concave up, it's probably going to be easier to draw the second derivative, so I'll take a crack at doing that. So I've plotted all of these second derivative y values as green dots, and now I'm going to connect them. And we have a problem because at -2, I'm undefined. So I don't really know what happens at -2. So I'll have an open circle because I'm not defined, but I also know that on the other side of -2, I have positive values. So I'm going to draw these open circles to show that that is when my second derivative changes from negative numbers to positive numbers. And now I'll keep going with a solid green curve. And so I'm looking for the second derivative to change sign. That will be a point of inflection. So that's going to happen here because I go from a negative value on this side to a positive value on the other side of -2. And it also happens right here at x equals 1. You can see my second derivative is 0, and I change from a positive to a negative. So this will be a point of inflection at x equals 1, and there'll also be a point of inflection at x equals -2. And I will be concave up when that second derivative is greater than 0. So I'm looking for this portion of the graph. Well, that's from -2 to 1. The last thing you're asked to do is to make a sketch, given that when x is -4, y is -5. So I'm going to highlight my points of inflection, the one max that I know, and I'm going to draw my function. We'll start from our maximum that we found, and we'll know that we're going to go down from a maximum. And we also had a point of inflection at 1, so this entire time I will be concave down. When my second derivative is above the x-axis, I'm concave up. I'll draw concave up in red. I'm going to be concave up this entire time. So I'm concave up the entire time the second derivative is greater than 0. And right at -2, I'm undefined, which means I'll have a point of inflection because my second derivative changes from positive to negative. Negative second derivative here means I am concave down. So my graph has to change concavity, but I'm still increasing because my first derivative was always above the x-axis. So I'm going to increase, but I'm going to increase concave down, so I'll look more like this, and this will have to be a cusp. So it shouldn't be a nice smooth curve. I'll accentuate that cusp. We have to increase, but do it concave down.